This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to be going over 50 of Python's built-in functions. So it's going to be like a speed run when it comes to learning Python's built-in functions. And there are actually 72, but we're just going to be covering 50 because these were the ones I found to be the most relevant. Starting with the first built-in function, absolute. And for this example, we're going to create n of type float, which will equal 1.25. Then we'll create n2, which will be of type integer, and that's going to equal -10. And finally, we're going to create a complex number, which is going to equal 3 plus 4j. Now with these three numbers, we can type in print absolute, which is shortened to ABS, and we can print all three of them. So n, n2, and n3. And what we're going to get as an output is the absolute of each one of these numbers. So the absolute of 1.25 is 1.25, the absolute of -10 is 10, and the absolute of 3 plus 4j is 5. And this one is more for mathematicians. And I'm saying that because personally I have no idea how to calculate the absolute of a complex number. It doesn't interest me in any way. And I'm not even interested in learning about it. But if that kind of math interests you, I definitely recommend you search how that works. Built-in function number 2, all. To use this, we're going to create a few variables. One will be a list of type integer, which is going to equal 1, 1, 1, 0, and 1. And we're going to call those voters. So 1 is going to represent a positive vote, and 0 is going to represent a negative vote. So you're either voting for or against. Then we can have voters 2, where not a single voter was for, and voters 3, where everyone was for. Next, let's print all of these. So we're going to type in all, pass in the voters, starting with the first one, duplicate that, and add voters 2 and voters 3. And what you're going to notice in the console is that the first one returned false, because not all of them were true. There was 1 0 which represents a falsy value. So all the values have to be true for this to return true. Now if everything is false, it's also going to return false because it's not all true. There is at least one falsy value. And finally, if everything is true or all of them are true, it will return true because all of the values are true. And while we're here, we're going to talk about built-in function number 3, which is the any function. So what I'm going to do is hold down Shift plus Option for this shortcut, and I'm going to replace this with any. So as you can see, it replaced all three of them. Now what any does is check that at least one of the values inside any iterable is true. So if we were to run this, you'll notice that the first one is going to return true because at least one of these values is true. On the second one, it's going to return false because there's not a single value that was true. And for the third one, all of them were true, which still fills that requirement where one of these have to be true for any to return true. Moving on to built-in function number 4, ascii, which you will probably notice me pronouncing as ascii in most of my videos. Now what ascii does is return a printable representation of an object that replaces non-ascii characters with escape sequences. And that was ripped directly from the documentation, if you didn't notice by how complex that explanation was. So what we're going to do actually is create an example, and we're going to type in Björn, en Björn, which in Swedish just means that this guy is a bear, which I found to be quite fun because this name also means bear. But what's important to notice is that we're using some non-ASCII characters. That's why I wrote this in Swedish. So what we're going to do next is print the ASCII of this text. And what you're going to notice as an output is that it's going to escape each one of those characters with the appropriate escape sequence. And what's cool about this is that you can also use it on iterables. So my characters, which will be a list of type string, please work. Come on, how do I, there we go. I don't know how pi went in there, but who cares? And here we can add some fancy symbols, such as that German symbol. I already forgot what that was. I think it's omega, the or, and finally, whatever comes from option +3, which I guess is a small left arrow. Anyway, we have 4 ASCII characters here, and what we're going to do is print the ASCII of this list. And again, it's going to return the escape sequence for each one of these symbols. And if you don't have a list, don't worry, you don't need to cry about it. You can just pass it in directly as a single character. So here we're passing in the yen, and that will give us back this escape sequence. Up next, we have built-in function number 5, bin, which also stands for binary. And all it does is convert a number into its binary representation. So what we're going to do is print bin there, done that, and just insert 1000. And then under that, we can do something silly like -5. It's not really that silly, it's quite normal. We can pass in 0, and finally we can do something such as 1,000,001. And now when we run this, you will see the binary representation for each one of these numbers. Built-in function number 6, bool. What does it do and how can we use it? Well, simply put, it just converts objects into booleans. For example, we can print the boolean value of Bob, and what that's going to return is true because this is a non-falsy value, or it's a true value. If you were to pass in an empty string, this is considered a falsy value, so that's going to return false. The same thing goes with numbers. If you add a number such as 0, that's going to be interpreted as false. Otherwise, if it's actually a number, it's going to return true. And I'm not saying that 0 is not a number, it just represents nothing. Or it doesn't represent nothing because we have none, but it represents a falsy value. Now, if you were to put none in here, which represents nothing, we will get false back because that is also considered a falsy value. And for one more example, we can pass in an empty list, which is considered also to be a falsy value. And if we add 1, 2, 3 inside this list, it's going to be considered a non-empty list, which will give us back true because it contains something. Built-in function number 7, callable. For this example, I'm going to create a variable called myObject, and this is going to be of type string containing Bob. Then I'm going to create a function called greet, which will contain a name of type string, and it will return none, because all we're going to do inside here is greet the following name. Hello, name, exclamation mark. Very simple function. Now what the callable function does is check whether an object is callable. So simply put, if we were to type in callable and pass in my object, you're going to notice that that's going to return to us false because this is a string which is not callable. And an easy way to understand this is to ask yourself, can you use parentheses on this object? This is usually how you call an object, and if you can do that, chances are it's going to be considered callable. Greet is something that you can use parentheses with. So if you were to pass in greet without the parentheses, callable is going to return true because this function is callable. And you can even pass in other functions such as the print function. And you'll see that that will return true because print is callable. We can use parentheses with it and it will work just fine. But for anything that's not callable, it's going to return false. And this can be quite handy if you want to check dynamically whether something can be called before actually calling it. I mean, it would be pretty sick if you could call an integer. I don't really know what that would do, but who cares? It looks cool. But don't try this at home, kids. It's not worth the crash. Built-in function number 8, cr, or character. And for this, we're just going to print chr, which stands for character, and pass in the Unicode value, because this is going to convert an integer to its corresponding Unicode character. So here, if we were to print this, we will get a back, because 65 corresponds to a. If we were to duplicate this 3 more times and type in 67, and then 69, and then finally 5000, you'll notice that it's going to give us all of these characters back. I don't even know what this is. It looks really cool. Do let me know in the comment section down below if you know what that is, just out of curiosity. But yeah, as you can see, we're getting the Unicode characters back. Built-in function number 9, complex. Now here, what we're going to do is first print complex with parentheses. And what this is going to do is create an empty complex number, such as 0j. If you want to create a complex number from 5, it's going to create 5 plus 0j. So it's going to populate it with 5. Now, if you do something such as 6 and 1, it's going to create a complex number with 6 plus 1j. And finally, we can also create complex numbers from strings. So here we can type in 7 plus 2j. And what we're going to get back is a malformed string because I'm a silly guy. And apparently that's because this cannot contain any spaces. So I'm glad I learned this with you guys because I didn't know that myself. But now when we run this, you'll notice 7 plus 2j. Built-in function number 10, dictionary. And I'm saying the full word because it's very easy to say the wrong thing there. And this constructor or this function is used to create or convert an object into a dictionary. So what we're going to do first is create an empty dictionary of type dictionary, and that's going to equal a dictionary. So using this constructor, you can create an empty dictionary. If we were to print this, you'll notice that we will get back an empty dictionary. Now you're not required to use this constructor. You can also just add an empty pair of parentheses and that will work just fine. But now you might be asking, how would you populate a dictionary using the dictionary constructor? Well, there are a few ways we can do it. One of the first ways we can do it is by typing in dictionary and passing in some key value pairs. That's going to work just fine. But there's also a more interesting way of doing that. So we're going to create something called container of list of type tuple that contains exactly two values, a string and an integer. And that's going to equal this, A, 1, B, and 2. And now we can pass in this container that contains exactly two values each. And what you should notice is that when we run it, we're going to get the same output. And the only rule you need to follow is that you can pass in any iterable as long as it contains pairs of two items or two elements. So something cool you can do is something such as this. We can type in A1, B2, and theoretically this should work. I mean, it's going to complain, but as you can see, it still works. Or you didn't really see anything because it's still the same value. So what we're going to do instead is AY and BZ. And when we run this, you'll see that it still gives us an output with these values because each element contains at least two elements, a key and a value. Okay, so that's already 10 of them. So I'm just going to take a quick break. I might be back later today or tomorrow. For you, it's just going to be instant. All right, so I am back, and that means we can continue with built-in function number 11, which is going to be dir. And by dir, I mean this one over here. So first of all, what we're going to do is print dir with the parentheses. And what it's going to do is return a list of names in the current scope. So if we were to run this, what you'll notice is this list of names, which is in our current scope. And this is what is available in our main.py file. Now, if we were to import something such as JSON, and we were to check what is the dir of JSON, we're going to get the names back from JSON. So we have JSON decoder, we have cached, we have doc, and we have everything from JSON, such as dumps and loads. So those are the names that belong to JSON. And we can also do it for the int type, and that will tell us everything we can do with int, or all the names that belong to int. And if we add an actual value such as hello, it's going to give us all of the names back from string. And that's going to include both the method names, the attributes, and the dunder methods. Built-in method number 12, divmod. And this method is used to perform division with the remainder. So what we're going to do here is print divmod 7 and 4. So how many times will 4 go into 7? You're going to find out right here. It's going to go in once with a remainder of 3. Now, if we were to do 3 and 2, we can find out how many times 2 goes into 3, and we will learn that it goes into 3 once with a remainder of 1. And it also works with decimals. So if we were to do 3.5 and 1.5 and check how many times 1.5 goes into 3.5, there should be a decimal, we will learn very quickly that it goes into 3 twice with a remainder of 0.5. Built-in function number 13, enumerate. For this example, we're going to create a variable called abba, which will be of list of type string, and that's going to equal the following members: Agneta, Björn, Benny, and Annie Fried. Now with this, we're going to create an enumeration, which will be of type enumerate. And all we need to do is pass in enumerate with the iterable that we want to enumerate. And that's going to be abba. And what's important to note here is that when you print this enumeration, it's going to give you back an enumerate object, which isn't really that useful on its own if you want to display information, but it is quite memory efficient. If you actually want to display the information, you're going to have to convert it to something visible, such as a list or a tuple. And if we run that, you'll see that each one of these elements will have their enumeration. So 0 for Agneta, 1 for Björn, 2 for Benny, and 3 for Annie Fried. And it's also important to note that this kind of object is exhaustive, which means once you retrieve the elements from it, they disappear from that object. So right here, we used all the elements in the enumeration, which means the next time we actually try to do that, we're going to end up with an empty list because everything was retrieved from this object. And to understand how that works, I recommend you search how iterators work. It will give you a good idea on how you exhaust these kinds of objects. Anyway, there's a better place to use this, and that's usually in for loops. So for I and member, in enumerate, aber, print, I, member, with a separator of this colon here. So that when we run this, we will get each member enumerated in a nice list fashion. And optionally, you can also provide a start to the enumeration. So you can start the enumeration at a different number, such as at 1. And that will just make it sound a lot more natural. Built-in function number 14, eval. And this function is used to evaluate code. And just as a disclaimer, you should only use this with sources that you trust. Never use eval with user input or random user input or anything from the internet, because it can mess up your computer if the wrong person uses it. Anyway, let's create something called some text, type string, which will equal this string over here, 10 plus 30 plus, or let's do times 2. So that should give us back 80, theoretically. Now what we're going to do next is print eval and pass in some text. As you can see, we're just passing in a string. And when we run this, we're going to get the result of whatever our string evaluated to. It's important that this is actually valid code, because if you were to pass in something that doesn't make sense, such as xy, it's going to give you a name error, because what it's doing here is treating whatever string or whatever input you pass in as valid code. And this is quite cool if you want to make a quick calculator. You can do something such as input, and now whatever the user inputs is going to work as a calculator. And that wasn't really a good example. So let's do 30 plus 2 and run that. So eval runs the code and returns the result. And again, use this with extreme caution, because if you were to put this on your website and someone was to put some sort of dangerous command, such as print, I just hacked you, this code will actually run and it will return the result. So they can do something such as wipe your computer clean, or, steal information from your program. So always handle this with extreme caution. Built-in function number 15, exec, or execute. Now, exec is the brother or sister of eval. It executes code from a source, such as a string. So for this example, we're going to create a source of type string, which is going to be a multi-line string. Because one of the major differences here is that we can run full files of code instead of just one line. So here we'll type in a of type integer equals 10, b of type integer equals 20. Then we can type in print a plus b, and below that we will do for I in range 3. So we're doing this in a text file. Print exec for loop, comma, I. That's going to be our make-believe source file. Now what we can do next is type in exec and pass in the source. It's going to execute the source code. And when we run this, we're going to get that code executed. One of the major differences here is that exec does not return anything. So if we were to, let's say, print the return value of running this code, you'll notice that we will get none back. It does not return anything. And something else to note is that once you run this code, it becomes valid code in your script. You can even print a, because we defined it here. Your code editor is not going to know about that, because as far as it's concerned, it's part of the string. But if you were to run this, you'll see that a is perfectly valid, because we ran the exec function, which actually ran it in our script. And since we defined it here, there won't be any errors. And once again, major disclaimer, do not use this with untrusted sources or random users. Built-in function number 16, filter. In this example, we're going to create a list of names, so list of type string, and that's going to equal James, John, Jam, my favorite name, and Bob. And what we want to do here is create a filter that filters the names that start with J. So what we're going to do is create a function called starts with J, and this should return a boolean. But what it's going to take is a name of type string and then return that boolean. Then we can return name at the index of 0 dot lower and check whether that's equal to J. And I think they also have something such as starts with. Yeah, they have it there. But we're going to use my silly approach because this is what I wrote in the notes. Now to use the filtered function, we just have to type in jnames and say that's going to be of type filter. And we just pass in filter with our function, which is starts with J, and the iterable we want to use it on, which are the names. And when we print this, what we're going to get back is a filter object, which is memory efficient as always. So what we have to do is actually convert it to a list if we want to see the result. And what you'll notice is that we will have James, John, and Jam in our list because we filtered out anything that did not contain J or start with J from our list using this function here. And with these kinds of functions, it's quite common to use a lambda instead of a full dedicated function. So what we can do instead is type in lambda and do everything here. So we can type in lambda name, which we will just abbreviate to N, or let's do S for string. And then we can do S at the index of 0 dot lower equals J. So we're just using a lambda instead of a function. And when we run this, we're going to get back the same result, except this time it was done on a one-liner. But as always, follow what's most readable to you. If you want to create a dedicated function for this filter, go for it. Otherwise, just use the lambda, as long as you understand what it does and will understand what it does months from now. Built-in function number 17, float. Now for this example, we're going to create a variable of type float called a, and all we're going to do is use the float constructor. Now when we run this, what we're going to get back is an empty float. And you're probably starting to notice a pattern here. If you ever use a data type constructor without passing in anything, you're going to get an empty return. And by empty return, I mean values such as 0 or an empty list or an empty tuple or 0.0. It's always going to be that kind of empty return. Not to be confused with none, which is absolutely nothing. Anyway, with the float function, we can convert practically anything to a float or anything that's compatible. So if we were to convert, let's say, the string of 10.5 to a float, that's going to work just fine. And we can also do it for booleans because booleans can be treated as integers. So that's going to be converted to 1.0. Things we cannot do it with is something such as the none type. That's just going to give us a type error. But yeah, it attempts to convert anything to a float. Moving on to built-in function number 18, frozenset. For this example, I'm going to type in fs, and that's going to be of type frozenset of type integer. And what we're going to do is type in frozenset and pass in an iterable such as 1, 2, and 3. Now, when we print this frozenset, what we're going to get back in the console is a frozen set. And you can tell it's a frozen set because it wraps the regular set in this frozen set wrapper. And what's special about a frozen set is that we cannot modify it in any way. It is immutable. We can still use some of the set methods, but otherwise we cannot append to it or remove from it. And what's nice about this is that it's actually hashable. So if we were to type in the hash of fs, we're going to get something back. With a normal set, this is not possible. We can't just type in, let's say, set of 1, 2, 3. That's going to raise an exception that we cannot hash a set. So if you ever need to hash a set, create a frozen set. Built-in function number 19, globals. All globals does is return the current scope's global variables. So if we were to print the globals, you'll notice that this is going to be included in the global scope. We have name, we have doc, we have package, and if we keep on moving, we still have a lot of other stuff here. If we were to type in x equals 10, you'll notice at the end that we will also have x in the global scope. So it just retrieves the variables from the global scope. And for built-in function number 20, we have something very similar, which is called locals. And when you're using this in the global scope, it just acts as globals. So right now we're going to get exactly the same return as we did with globals. As you can see, x is still here. But to show you how locals actually works, we're going to create a sample function. So def sample function to return none. And inside here, we're going to create a channel of type string, which we will give the value of indently. Then we'll type in x of type int equals 1, y of type int equals 2. And here we will print locals. And we're just going to change this to z type int to keep it completely separate. Now, what you should notice when we print this sample function is that we will get those local variables back, the ones that are included inside the function, because that's what's local to that function. If we were to print globals here, we're still going to get everything from the global scope back. This is everything that's visible from inside this function. So if we go all the way to the back, you'll see that sample function is in the global scope. We will still get z back, but something that we're not going to get back are the local variables that were inside the function. So this is quite useful for understanding what's visible in which scope in your current script. Built-in function number 21, hash. And what hash does is return the hash value of an object as an integer. So to show you how that works, we're just going to print the hash value of the frozenset, which contains 1, 2, and 3. So that's going to be our first hash. And what we will get back is this hash value. Now another hash we can print is the hash value of browns. And I was actually just looking at my notes and I was wondering, why did I put browns? But I remember, because I'm a comedian, hash browns. And when we get the hash of browns, what we're going to get back is this hash over here. Then we can also do it with things such as tuples. So hash of the tuple of 1, 2, and 3. And that's going to give us back this hash over here. So yeah, it just gives you the hash back of any object. Up next, we have built-in function number 22, help. No, that was not a request. It's actually called help. And when you run this without any arguments, it starts an interactive console. So inside here, even though there's this annoying bar, you can start typing things such as print. And it's going to give you back the information for print. It's actually a console inside the console. And to exit, we will just type in Q. And it's going to say you are leaving help, and your process will finish with an exit code of 0, which is what we wanted. Alternatively, you can actually pass in the function that you want to get help for into the help function as an argument, and it will give you back the documentation and some other useful information for that function. You can easily also do this for your own functions. So if you have a function called hello, which takes a name of type string, returns none, because all it does is print the f string of hello name. And I actually just typed in hell here, but it should be hello. Although saying hello can be hell sometimes. And what we're going to do is add some doc strings, or just a doc string. I guess one should be enough for this. A function that says hello to the user, to a name provided by the user. And here we're going to remove the return, because the return type is going to be none. The type of name is going to be a string. And here we can just type in the name you want to greet. Now, if we were to print help, or actually we don't have to print help for that, we can just type in help and pass in our hello function. We should get that documentation back. So as you can see, it says help on function hello in module main. And then it gives us back the doc string along with the function. So this is quite useful if you want to quickly find out what a function does while you're in the console. Personally, I would never use this in a script directly because it's, quite annoying. We can just hover over that and we will get the same documentation back. Moving on to built-in function number 23, ID. And what ID does is return the identity of any object. For example, we might have a user of type string called indently, or we might even have a number of type integer, which is equal to 42. Every object in Python gets its own ID. And to find out what that ID is, all you need to do is print the ID of that object. So ID of user and ID of number. And that's going to give you back the current ID. And this is quite useful if you want to check the identity of several objects. For example, we might have a list called L1, which will be a list of type integer. And that's going to equal 1, 2, and 3. Then we duplicate that downwards and type in L2. And what we're going to do next is compare both of these lists. And to do that, we're going to check that L1 is equal to L2. And right below that, we're going to check that L1 is L2. Now these perform two different operations. One checks for the values and one checks for the identity. When we run this, you'll notice that L1 is L2 is going to return false because they are not the same object. They contain the same values, but they are not the same object. And that's why L1 is equal to L2 returns true, because they contain the same values. Now, if we were to do something such as L2 is equal to L1, we're going to get true because L1 and L2 are the same object. They both have the exact same ID. And we can verify that by printing the f string of L1 equals and L2 equals. And you'll see that that's absolutely not what I wanted to do. So we have to actually check the ID of L1 equals and do the same thing for L2. And then we can see that the ID is the same for both of them because all we did here is create an alias. But if we were to give this back its original value, you will notice immediately that the ID will be different down here. And maybe it's not so easy to see with the first 3 digits, but at the end you'll see that we have some different numbers. Built-in function number 25, int. And this is just used to construct integers. So for example, we can create something called an empty integer, which will just equal the int constructor. And when we print this, what you're going to get back is 0, because again, every time you use a constructor without an argument, it's going to create the empty value of it, or like the base value of it, which is going to be something such as 0 or 0.0, and so on. And something else we can do with the int constructor is convert floats to integers. So for example, we can have something such as 1.9 or 1.4, or even the string of 4. And this will attempt to convert each and every one of these to an integer. And what we will get back is 1, 1, and 4. One thing that's quite important to understand is that it will always round down. That's why we have 1 and 1 here. Even if it was 1.9, it opted in for rounding that down. Built-in function number 26 is instance, which is used for checking types. So for this example, I'm going to import from typing the any type and the iterator type. And there's a good chance this won't actually be for this example. It's going to be for future examples as well. So I'm just going to leave these imports at the top for the rest of this tutorial. Anyway, for isInstance, we can check whether a type is an instance of another type. For example, we can check whether 10 is an instance of integer. Or we can also check isInstance text of type string or integer. So the first argument is the object you want to check for. And the second argument is the type you want to check for. And here we created a union type, while here we only created a single type. We didn't create these types, but that's what we provided. And when we run this, you'll notice that I actually didn't use isInstance here. So you're probably asking me, am I drunk or something? But the answer is no, I did not drink. It's early in the morning. So once we insert isInstance, it's going to return true because 10 is of type integer. It is an instance of integer. But if we add a string, it's going to return false because s, or this string, is not an instance of integer. And that can be quite useful if you're checking for user input. You can say user input of type any, which in most cases is going to be a string if you use the input function, but it can also be anything. So here we'll insert a tuple of 1, 2, and 3. And then we will check if isInstance user input of type integer, then we will execute the following code. Int, something very simple. elif isInstance user input of type tuple set or list. We will print tuple set list. And just to keep this simple, we will just say unknown type if it's not one of those two types. Now, when we run this code, what we should get as an output is that this tuple here of type any is actually of type tuple or set or list. Or it's not really of that type, but that's what we're printing. Because as far as our program is concerned, it's one of these 3 types. Otherwise, if we change this to text, which is of type string, it's going to print unknown type because it does not satisfy any of these requirements. We can also change any to a list, such as 1, 2, and 3. And when we run this, the isInstance check will check that user input is again of one of these types. And if it is, it's going to execute the following code. So it's quite useful for checking for types. Built-in function number 27 is subclass, and it's going to look like this. And what it does is return whether a class is derived from another class, or if it is the same class. So in this silly example, we're going to create a class called parent and a class called child, just to make this as simple as possible. And as you can see, child inherits from parent. Now below that, we can print a subclass. Is the child a subclass of parent? And we can also do the opposite, check whether a parent is the subclass of a child. And by this point, you can probably imagine that the latter is not going to return true because the parent is not a subclass of child. It's the child that's a subclass of parent. So simply put, it just checks whether a class is a subclass of another class. And we can also do this with built-in types. So for example, we can type in print is subclass, boolean, and integer. Is boolean a subclass of integer? And that's going to return true but it's not going to work the other way around. Integer is not a subclass of Boolean. And we can verify that just by using this method. And God, that's a lot of purple. Built-in function number 28, iter, which stands for iterator. And what it does is create an iterator from any object. So what we're going to do here is create a queue, which will be of type list of integer, and that will equal 1, 2, and 3. Because we want to create an iterator from this queue. And to do so, we will create something called my iterator, and that's going to be of type iterator, which I removed from the import, so I'm now suffering the consequences, but now we have it back at the top, so everything's okay. And that will be of type integer. And here we will type in iter and pass in the queue. As you can see, we're using the iter method, or the iter built-in function. Now with this, we can print in next and pass in my iterator and duplicate that maybe 3 times. And what we're going to get back is an element each time we use the next function on our iterator. So we get 1, 2, and 3 back. Or we can also convert it to a list if we just want to see what's inside, and we will get that list back. But again, iterators are exhaustive, which means that if we were to try to print this list again, you'll see we will get nothing back because we exhausted this iterator. We took everything from it. So the next time we actually tried to convert it into a list, there was nothing to grab from it because it's now empty. Up next, we have built-in function number 29, len, which I always refer to as length. And to use it, we're going to create some text of type string, which will equal my name is Bob. And what we want to do is find out how long this text is. So we will print the length of this text. And when we run this, what you should get back is 15 because it contains 15 characters, including spaces. And you can also do this with iterables. So here we can type in items of type list of string. That's going to equal a cup, an apple, and a plant. And here we can print the length of this list. And what we should get back is 3 because there are 3 elements in this list. Built-in function number 30, list, or the list constructor. So as always, first of all, we're going to create an empty form of whatever type we're using. So empty list of type list will equal list. And when we print this, what you should notice is an empty list. But you can also create lists from strings. For example, we can have characters of type string is going to equal A, B, C, D, E, F, G, H, I, Z. And when we print the list of these characters, what you're going to get back is a list of each one of these characters. And it actually separated them. Or another example would be if you had a tuple called myTuple, type tuple, which contains an integer and an integer. So here we're going to have some coordinates, for example, 1 and 5. And if we were to print this tuple to a list, what we should get back is a list version of that tuple. Built-in function number 31. Map. And what a map does is apply a function to all the elements in an iterable and returns the result. So to show you how that works, we're going to create a function called square. And that's going to take an integer and it's going to return to us an integer. And all we need to do is return n times n. Now we can type in squared, which will be of type iterator of integer. And I keep on removing the import, so I have to do this every single time. Is going to equal a map, because map is going to return an iterator. And here we can pass in the function that we want to use on the iterable. So 1, 2, and 3. First comes the function, then comes the iterable. And when we print this, what we're going to get back is a memory efficient object, which is actually a map object. So to actually see the results, we're going to have to extract those values. And here we can just type in list, and we will get back our squared values. And as always, we can do this using a lambda. So here we can type in all upper, which will be of type iterator of type string. And this time we're going to add a lambda function that takes a string and uppers that string. Then we just need to pass in some names such as Bob and Sandra. And just like that, we can print the list of all upper. And what we should get back is each one of those elements uppered. So it's up to you whether you want to use a lambda or a function. Once again, it's a matter of preference. Moving on to built-in function number 32, max. And this one is quite self-explanatory, but there is a hidden argument that a lot of developers don't know about, which I will share with you in just a moment. So here we'll type in list of type integer, and we will pass in the scores from my notes. 99, 10, 4, 100, which is obviously my score, 25, and 45, which is Bob's score. Now, if we were to print the max of these scores, what you're going to get back is 100. And that's quite self-explanatory. But there's something else, as I mentioned, that a lot of people don't really use. So here we're going to create a list of type string, which is called names. And we're going to pass in Bob, James, and Stephen. And this time we're going to print the max of these names with a key. And what the key does is tell Python how we want to sort these, or how we want to determine which one should be the max value. So in this case, we're going to say that the one with the longest length will be the max value. And when we run this, we will get Stephen back. And you can also pass in a lambda. As long as it returns an integer value, it should be able to sort the names and determine which one is the max value based on which has the highest value. And for built-in function number 33, we have the opposite of max, which is min. So here we can just type in min instead of max, and it's going to return to us Bob. If we go all the way back to our scores, we can also add min here, and it's going to give us the minimum value of these scores, which is 4. Next, for built-in function number 34, we have next. And I literally mean next, which is used with iterators and generators to grab the next value inside that generator or iterator. For example, we might have something called my iter, and this time I did not remove the iterator import, so we can just use it directly. That's going to equal an iter from the range of 3. So we're just turning range into an iterator, which would be the equivalent of just passing in a tuple and doing 0, 1, and 2. Same thing, but I just want to use range here. Now with this, we can print the next value in this iterator, which if we do it once, it's going to grab 0. If we do it twice, it's going to grab 0 and 1. Do it 3 times, it will grab all the values. And we do it one more time, it's going to raise an exception because there are no more values in that iterator. And we can actually demonstrate that by converting the iterator to a list. You'll see that there are no more values in that iterator. If we remove 2 of these next calls, we're going to have 2 values left in the iterator, which we just exhausted because we used the list constructor on this iterator. Now, this is not a dedicated video on iterators. I absolutely recommend you search on YouTube for some good examples on where to use iterators and how they work. I have a few on my channel if you feel like searching for them, but otherwise let's move on to the next built-in function, which is built-in function number 35, open. And open is used for opening files and working with streams. For example, you might have a file of type string, and that's going to equal secret.txt. And right now I have this file in the same folder, so it's very easy to refer to, but let's pretend I want to read the contents from this file. One very easy way to do that is to type in with open file in read mode, which is the default, as f, and print f.read. Here we're opening the file so we can actually work with it. And when we run it, we should get the contents of this file, which is not embarrassing at all. Built-in function number 36, odd. And what it does is get the Unicode code of a character. I had to read my notes like 10 times because that just was so hard to say. Unicode code. Anyway, print the odd of A, of this symbol, and of this symbol. And what we should get back is the Unicode code for each one of these characters. And from what I read on the internet, odd is short for ordinal, which is something I didn't know about until today. Moving on to built-in function number 37, pow, which sounds like a comic book effect. I love it. But what pow actually does is get the power of a function. But let's take a look at what pow actually does. So here we're going to type in pow, and as you might notice, we have base, exponent, and mod. So first of all, we're going to do 2 to the 3rd power. What we should get back is 8, because 2 times 2 times 2 is 8. If we do that with 5, we should get 2 to the 5th power. And something cool about this is that we can actually do something such as provide modulus division at the end. So right now, if we were to do 2 to the 5th power and add modulus 3, it's going to tell us how much we have left over from that operation. If we divide it by 3, we get the remainder of 2. Personally, I don't know what I would use that for, but it's good to know that it exists if you are a mathematician or need to do some calculations. Although I would probably opt in for using the keyword, because seeing 2, 5, 3 looks illegible. Anyway, built-in function number 38, print. And by this point, we've been using print a lot, but there are some secret features, or I don't know why I said secret. There are some lesser known features that come with print that you should probably know about if you use it a lot. For example, we're just going to start off with printing something simple, such as hello world. And what this is going to do is print it to the console. We can also print, let's say, 1, 2, 3 as arguments and provide a separator, which could be this comma. And when we run that, we're going to get these 3 arguments with the comma as a separator. But you can also add a dash if that's what you want. And it will use it as a separator for these 3 arguments. But next I'm going to show you something similar to this, which I find very useful. And to demonstrate that, I'm going to create a list of people, which will be a list of type string. That's going to equal Bob, James, and Sandra. Then here what we're going to do is unpack these people. So we're going to use the asterisk followed by people. We're going to add a separator, which is going to be a comma. And finally, we're going to add an end. Now the default for every print statement is \n, which creates a new line. But we can modify that to be whatever we want, which in this case will be a full stop. So now when we run this, we're going to have a very beautiful list. If we don't add the new line and we just add a full stop, you'll notice that the next time we print something such as hello Bob, it's going to be displayed at the end without a new line, which is quite annoying. So usually you might want to add a new line so that you get them on different lines. And of course, the full stop should come before that. So I find both of these keyword arguments to be very useful, especially when you are unpacking elements into print. Moving on to built-in function number 39, range. And all it does is create a range. So if we were to create a normal range, we can do that by typing in range 10, or that's of type range, so that should equal a range of 10. Then we can print this normal range, and what we will get back is a range from 0 to 10. And if you want to see that in the form of a list, just convert it to a list, and you'll get those 10 numbers back. Now we can also specify a certain section for a range, so for example 5 to 10, and that will give us a range of 5 to 10 back. 10 is not inclusive, so that's why we only get 5 elements up to 10 without actually having 10 in it. That was a very complicated way of saying it. And something else you can do is provide a step. So from 0 to 10 with a step of 2, that will give you back these numbers. And finally, I'm going to be sharing with you a forbidden technique on how you can get a negative range back. Because right now you might be thinking, that's easy, just 10 to 0. But look what happens when you run that. You get an empty list back, if you convert it to a list, of course. And this is not what we want. So unfortunately, if you want to get a list that goes from 10 to 0, you're going to have to specify a step of -1, so it can count downwards. And it's not really a forbidden technique, it's just something you need to know when you are programming in Python. Up next, we have built-in function number 40, repr, which stands for representation. And to use it, all you need to do is type in repr of 10 or repr of the string of indently, and it's going to return to you the representation of that object. So for 10, it's just going to return 10, but for this string, you might have noticed that it also included the quotation marks, because that's the representation of a string. And in general, this is going to return information that's useful for the developer. For built-in function number 41, we're going to be looking at reversed, and reversed returns a reversed iterator. So in this example, we're going to create a sequence, which will be a list of type integer, and that's going to equal 1, 2, 3, 4, and 5. Now, if you were like me when you first started learning Python, you might have tried to reverse something by using the reversed built-in function. And what you will notice immediately is that when you do this, you get a reverse iterator object back, which is quite useless because all we wanted is 5, 4, 3, 2, 1, but instead Python gave us this silly stuff. So what we're going to do instead here is create a reversed object, which will be of type iterator of integer, and that's going to equal reversed with the sequence. Now we can print the list of R, and what that should give us back is the actual list reversed. And the reason it creates a reversed object is because that is incredibly memory efficient. And you're going to hear me saying that a lot. Memory efficiency is quite important in Python, especially when you're working with such a slow programming language. It's good to be as efficient as possible with your resources. Otherwise, if you don't really care about that efficiency, you can use the oldest trick in the book, which is sequence : -1. And that's also going to give you the reverse back using slice notation. Moving on to built-in function number 42, round. And for this example, we're going to create n of type float, which will equal 1, 2, 5, 4, 9. It's very important we follow this number. 1, 2, 3, 4, 5, 6, 7. And what we're going to do first is round n to 5 decimal places. And what you should notice in the console is that this number will have been rounded to 5 decimal places. Now, if we were to do this with 3, what we will get back is a number rounded to 3 decimal places. If we do it with 0, we're going to get a number rounded to 0 decimal places. And I believe without the arguments, it's just going to give you an integer back, which is perfectly fine. But we're going to leave it as a float by providing 0. But something that a lot of people don't know is that you can also do it with negative values. So if we do -1, for example, it's going to start rounding the whole number part. So 49 is going to be rounded to 50. If we do it with -3, it's going to round the 1,000. So 13,000 instead of 12,550. So it's quite cool that you can actually round it in both directions. Next, we have built-in function number 43, set, which is used to create a set from scratch or to convert an object into a set. So here we're going to create something called empty set, and that's going to equal a set. Now, if we were to print this empty set, what we're going to get back is this set over here. And unfortunately, we can't create an empty set with empty curly brackets because that belongs to the dictionary. As you can see, if we were to hover over that, incompatible types, here we have a dictionary, but what we actually wanted was a set. Thank you, MyPy. Anyway, what's important to know about sets is that they cannot contain duplicates. So you might have a duplicate list, or I'm going to call it list with duplicates to not really change the example. And that's going to be a list of type integer. Then we'll just type in 1, 1, 1, 2, 2, and 3, 3, 3. Now, if we were to convert this to a set, you'll notice that the set will only contain 1, 2, 3 because a set cannot contain duplicates, which is also a good way to remove duplicates from a list. Built-in function number 44, slice. To get started with this example, we need to create a list of type integer, which will be equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we could have easily used a range here, but I decided not to. Now, first of all, we're going to create a slice called step2, which will be of type slice, and that will equal this slice over here. And first of all, we're going to type in none, none, and 2. And what this is trying to replicate is the slice notation. So usually you would do something such as : 2 if you want to step by 2. In this example, if you don't insert anything, you need to insert none. So right now we're creating a reusable slice object. And what's cool about this is that we can print numbers and use this slice object inside here, if I can spell it. And when we run this, it's going to work as you might have expected it to. And yes, it works the same as if you were to use : 2, but the advantage of this approach is that if you were to use this slice in many places in your code, you just have to update it in one location. And something else we can do is change this to rev for reversed and change 2 to -1. Now we have a slice that reverses any iterable. Or maybe you just want to grab the first 5 numbers. You can do 0 to 5. And at this point, I'm just going to convert this to my slice since I'm changing it so much. And what you should notice in the console is that it will grab the first 5 numbers. So it's quite useful for creating reusable slices. Moving on, we have built-in function number 45, sorted, which is used for sorting iterables. For example, we might have something called mixed of type list of integer, and that will equal 1, 5, 3, 2, and 4. And what we're going to do next is print sorted of this mixed list of integer. And what it should give us back is a sorted list. And that was a simple example. But now imagine we have a list of names, which as always will be of type string, which will equal Bob, Amanda, John, and Charles. And if we print the sorted version of these names, and provide a key which can be set to length, it's going to sort these by length. So right now, if we were to run this, we'll get Bob, John, Amanda, and Charles. Without this, it's going to sort it by ASCII value. So if we remove that, you'll see Amanda will be at the beginning, then Bob, then Charles, then John. And something else we can do is reverse it. So if we set reverse to true, it's going to give us the result and then reverse it. So you can easily sort and reverse that iterable in one simple function call. Moving on to built-in function number 46, string. And string is used for creating empty strings and converting other data types to strings. For example, here we have an empty string, type string. That's just going to equal this string over here. Now we can print the empty string, and we're going to get nothing back or nothing visible back because it's an empty string after all. But if we print the representation of this empty string, we will get those quotes back of the empty string. And we can use it practically on any data type. So if we were to print this string of, let's say, true, of the Boolean data type, of none, and of 100, what we should get back is the string of each one of these. And the reason this is so cool is because if you were to use the string of none and call.upper, you can now use none as a string. So you can actually return a huge none instead of a small none. This isn't really a real example. I don't know where you would use this, but just to demonstrate that you can do that, I chose to use this example for some reason. Up next, we have built-in function number 47, which is sum. And the sum just grabs the sum of an iterable. For example, if we have some game scores, type list of integer, and that can equal 1, 10, 40, 200, 25, and 25. We can then print the sum of these game scores, and it will return to us the total sum. Optionally, you can also provide a start value, which can be set to, 1 million, if that's what you want. And it's always going to use that value as the starting value. So also, if you have an empty iterable, such as this one, it's going to return that start value to you in case there's nothing there. Built-in function number 48, tuple, which is used for constructing tuples. So as always, let's get started by creating an empty tuple, which will be of type tuple, and that will equal tuple. Then we're going to print this empty tuple, and what you should get back is an empty tuple. But also imagine you have some sort of list, which is called coordinates of type, not string, but integer. And that's equal to 1.5 and 5.0. Python obviously will not be happy with the annotation of integer when you provide floats, so let's fix that. But after that, we can print the tuple of these coordinates because these coordinates shouldn't really change. These are coordinates that will remain the same forever. So now we were able to convert that list to a tuple using the tuple constructor. Built-in function number 49, type. And in this example, we will create some elements of list of type any because it can contain anything. And we have to re-import that from typing. And that's going to equal Bob, 10, true, 1, 2, 3. So a nested list and a nested set of 1, 2, 3 as well. So we have a lot of data types here. And for element, in elements, we're going to print the type of that element. And when we run this, we should get the type of each one of these elements back, such as string, integer, boolean, list, and set. So all it does is tell us what type an object actually is. And finally, for built-in function number 50, we're going to be covering the zip function, which is used to zip elements together. So here we're going to create A of type list of string, which will equal A, B, and C. Then B of type list of integer, which will equal 1, 2, 3, and 4. Then we have C, which is a list of type Boolean. And that's going to equal true, false, true. Next, what we're going to do here is create a zipped object, which is going to be an iterator, which contains a tuple with these three elements, the string, the integer, and the Boolean. And that's going to equal zip A, B, and C. There's something that's not right here. And of course, Python's complaining because the tuple requires square brackets, not parentheses. But now if we were to print the list of this zipped file, or not zipped file, this zipped object, what we should get back is a list of tuple with a string, an integer, and a boolean. And you're not required to use this type annotation. As always, I use type annotations because I personally find them incredibly useful. But for a lot of you, it might just be sufficient to just type in zip ABC if you don't want to go through the effort of providing type safety for your program. But something cool about this is that you can type in now for A, B, C in zipped, print A, B, C with the separator set to whatever separator you want. And when you run this, you can use each one of those separately. But let's go back to the previous example where we converted the zipped object to a list. There's one thing that you probably noticed, which I did not mention, and that is that 4 completely disappeared. And that's because zip will only zip the shortest length of all the iterables, which means if you have an iterable that has, let's say, 3 elements, it's only going to zip up until 3 elements, ignoring everything that comes after it. Even if you have, let's say, 2 iterables with 4 elements, it's still only going to zip up until 3 elements, because this is the shortest length it found. And when you run that, you'll see we will only get up until 3. Now, if you want to ensure that there's 4 elements, you're going to have to set strict mode to true. And what this does is raise an exception if one of the iterables is not of the same length. So yeah, I can't believe it, I made it to the end of this video. I've been talking for over 3 hours now. Do let me know in the comment section down below what you think about this video, whether you want more videos like this one in the near future. It takes so much time to record, and then now I still have to edit it. So if you enjoy this kind of video, do let me know in the comment section down below. But otherwise, with all that being said, as always, thanks for watching, and I'll see you in the next video.